Central ITS division at the university. I'll begin this session with a brief overview of our IT environment and the demands of that environment, and then discuss the patching arrangements we have in place for our servers. Please feel free to raise questions as we go, especially during the demo. If you could raise questions if you want to see something. It's kind of our real environment, it's our real test environment. As long as the internet's working, I'll be RDPing back to my real desktop. So feel free to ask questions that may be completely unrelated to this session, about the tools you might see me using or anything like that. So at Otago we have around 20,000 students and around 3,500 to 4,000 full-time equivalent staff. And there's, at varying times of the year there's some overlap with staff and postgrad students, and so maybe in February we have up to 25 to 30,000 users on our network. IT and user and client base is very diverse. We've kind of supported BYOD before there was BYOD. Students kind of just brought their devices since when they had them. So it's kind of led to a wide range of devices that we support. Many unmanaged devices, maybe only 50%, even less, actually on a domain and managed. For staff, that's around 40 to 50% Mac users, perhaps students, not really sure. And there's maybe 1 or 2% using Linux, as professors and things. So using our email environment as an example, we provide support for OA, Outlook for PC, Outlook for Mac, any ActiveSync capable device, any IMAP capable device, within reason. So we provide a sort of best effort. This is how you should configure it, and maybe log a call with Microsoft if it looks like there could be something wrong with the actual IMAP protocol. So supporting such a wide range of clients, we're kind of like running our own mini internet, I suppose. So we have to sort of do our best effort and have a really reasonably regimented patching regime for our core infrastructure like AD, Exchange, DNS, DHCP, because if there's an exploit that comes out, generally we'll have an infected machine on a network pretty quickly. Our user base is active pretty much 24/7. We have staff work 8:30 to 5 mostly, but there's a few of them always various places around the world, complaining they can't get to Outlook from various places in China, and or if they're in Egypt or somewhere else where where a lot of spammers sort of mount their attacks from. They might not be able to get to their mail or their service because we're denied them for some reason. So it's quite challenging at times. And as such, our window for patching and rebooting, particularly standalone systems, is quite narrow. Things like AD, it's good because you can reboot servers without interrupting services, but we do have a lot of standalone servers, FileMaker Pro and various other things, which the service just goes down when it's being rebooted, so we have to find an appropriate time for that, which can be quite hard. From a physical perspective, we have 2 major data centres in Dunedin. Well, we call them major, I guess reasonable size for New Zealand. And a third in Dunedin is also for a sort of witness failover for Exchange and SQL Server. We also have some in smaller data centres, and I don't know if you'd call them data centres, but closets with some stuff in them in Invercargill, Christchurch and Wellington and Auckland, just down the road I think. And we also have a small presence with an infrastructure as a service provider in New Zealand for some DR, DNS and web, should we lose our internet connection for an extended period of time. And finally, we also have a client of a lot of cloud-based products, Office 365 being one of them, but also various offerings from Oracle and other major cloud vendors. A quick sidetrack here. This is my daughter. Another one of shots of our data centre. She comes in with me, into the data centre on the weekend if I have to come in for whatever reason. Physical server won't reboot. On this particular weekend, we caused an outage to our SharePoint environment with this, regime I'm about to show you. Basically wiped out the 2 SQL servers that support our SharePoint environment. The first server sort of did the right thing. It patched. It failed its databases over to the second. Installed its updates, rebooted, came back up. Second server started, a couple of hours later, second server started patching, failed its databases to the primary, or now the primary, the first server, and happily started patching, installed its Windows updates, probably took down SQL Server while it was doing it because it installed .NET updates or whatever, rebooted, and just as it was starting to reboot, or while it was rebooting, the first server blue screened with a driver issue. So the second server knew that it didn't have the latest copy of the database because someone in SharePoint had probably written a bit of data by that time, either a search index or whatever. So when the second server came back up, it didn't bring up half the databases. So at that point, we might have had some site collections still running, maybe search, and then a couple of hours later, it kind of followed suit with the same driver issue and blue screened and went into Windows recovery mode as well. So it was a bit of an epic fail, and quite a hard one to kind of prevent, to work around, because you could have sort of a check file or whatever, but if the server's going to crash after 8 hours or in hours, how do you know? How do you catch that case? And so that was quite a funny one in a way. We've installed updated drivers now, so hopefully it won't happen again. Within our team, we've experienced a major growth in the number of servers we manage. There's been 3 primary drivers for this, I think. Firstly, usual cost recovery stuff. Departments have been required to reduce their costs associated with running their servers, because we have 150, 200 departments, and a number of them run their own servers for research purposes and other reasons. Sorry, lost my chain of thought there. But many of the business critical ones and significant systems, what we call significant systems, have been brought back into our team, either as housed or what we call hosted systems, where we manage everything pretty much but the application. Like if it's a FileMaker Pro thing, we'd give them access to the FileMaker Pro console, but not the actual server itself. Secondly, increased demands from users have resulted in additional systems being built to increase business productivity or increase IT learning resources for students. We have lots and lots of those e-learning type systems. Thirdly, we commissioned a secondary data centre in Dunedin, the one we saw before, in late 2010, and this sort of changed the way we architect systems. It was before, I guess, as the cloud was still sort of beginning to grow, we kind of run our own mini cloud, I suppose, in a way. So any critical or significant system, we generally build it in an active-active config with a load balancer, and so we end up with double the number of servers. So more servers to manage. The graph here is showing just the number of virtual servers we had running in our environment since 2010. Sort of late 2010, we started a bit of a drive to get rid of most of our physical servers. We had a couple of hundred, maybe a few more. So most of those got virtualized, which is the initial sort of bump. And then since then, it's just been the fact, as I mentioned before. We still have around 100 physical servers we run for DNS, DHCP, AD, those sorts of things, which we don't necessarily trust virtualizing. I don't know, it's the usual. We're slow adopters. I guess the key message I'd like to pass on to you today is that when faced with sort of a large, diverse, complex problem, is they generally demand creative solutions. A single box solution like SCCM will only get you sort of 80% of the way. We chose to use SCCM for various reasons. SCCM maybe got us 80, 85% of the way. And other products we tried might have only got us 60, 70% of the way, which is one of the reasons we chose SCCM. But either way, you sort of got to create your own, what I'm calling glue, I guess, to make it all work for you, to really get the benefit, at least as an engineer. For the users, maybe not so, but for an engineer, if you want to get that, be able to relax a bit more on the weekend, you really need to get it a bit past the 80% mark to be patching most of your servers if you can, automatically. With the framework we've put in place, we can leverage any existing software installation scripts we've written, which we've done, and any in-house or vendor-supplied restart or validation scripts for business object servers, rebooting, or various other third-party software. But without sort of needing to know that from the SCCM admin's point of view, we don't really need to know anything about those third-party systems. They can just create a little scheduled task, and it'll kick off at the right time, and at the end of the patching, it'll kick off another scheduled task if you've got one there. So it allows the framework that we built to have minimal maintenance, and also allows us to switch to another product in the future if we want to. If Microsoft, for whatever reason, say it's only the cloud now, and we don't want to go to the cloud, and we want to keep running something on premise. So not sure if we would want to, but we should be able to sort of port those scripts we've written as we need to another system. So how do we patch the servers? Well, I guess I'm marking it as a creative solution to a problem with diverse and sometimes conflicting requirements. I'll start with what we used to do. Around 5 years ago, we had 200 to 300 Windows servers, which you sort of saw on that graph before, and we manually patched them all. The manual patch process was pretty much that. Short of manually downloading them, we were using WSS. There wasn't much of a harder way to do it. But log into every server and manually install the updates. It relied on someone in the team. We didn't really have a formal process or anything, so it relied on someone on the team actually remembering to go and look on a Patch Wednesday. We call it Patch Wednesday because it's New Zealand, and actually assess whether there might be an update there that's important. At that time, what we did was just pick that one update, like if it's a Kerberos patch for AD, we'd just pick that one update and apply it maybe to everything, or but just that one update or just 3 or 4 updates would apply, and we wouldn't necessarily apply like IE updates to our domain controllers or anything like that. So if you were on one of those and you weren't in the right WSS group, you'd have to unselect the updates because you want to be consistent across all your servers, and so it was pretty tedious. And as this number of servers grew, it took a much longer and longer chunk out of your weekend or evening. Let's go to the next slide. So how do we turn that around? Within the team, we often have what we call robust discussions. To an outsider, they might look like we're fighting, and perhaps we are, but no, I don't think we are. Just to be clear, we do have a good working relationship within our fellow engineers, to the point where any proposed solution, we'll welcome it on its merits, and perhaps, someone here, if they're observing, might think we're a bit crazy, but we're open to any ideas, and so people will often think we're fighting, but we're not really. At least I don't think we are. So. We did try, as I said, a couple of other vendors' products. We also had a brief look at Orchestrator. Orchestrator probably could have done what we needed, but I guess we weren't really wanting everyone in the team to have to learn SCCM and Orchestrator and stuff to know what to do if there's a problem and that sort of thing. So here are the broad concepts we came up with. We all agreed that we need to try and patch as many possible automatically, so we didn't have to log into all the servers anymore. And we were acutely aware we couldn't just go out to our clients and demand a regular outage window without sort of being able to give them some care sessions. So, various departments saying, I've got an exam on Friday night, or the library's open extra long on the Saturday because people are studying for exams. At university, there's things you never think of come up, and you have to sort of move the server from patching on Friday night to patching on Saturday night, or even patching it manually on a Monday if you have to, or something like that. So we needed a monthly waitlist window, so we had to go and demand that from our clients essentially. But then we had to say, well, yes, we'll let you, move a few servers about as needed for the various things that come up. So what we came up with, I'll show you shortly, is we've patching groups. There's a lot of them. 2 hour windows from 6 p.m. on Wednesday, for dev and test, all the way through to 6 p.m. on a Sunday. So there's not a lot of patching windows during the day. The ones we use during the day are generally for things like SCCM itself, or VMware, or sort of underlying infrastructure, which you really want available on the weekend too. And you don't want it compromised if something else on campus gets compromised. So we wanted to reuse all our existing software and scripts that we had, because we had a number of software install scripts for when we build machines. We build machines from VMware from a template. We don't use SCCM still. Maybe we will one day, but today we don't still. We just use a VMware template and have a build script. So we wanted to reuse those scripts that were there for installing software like our backup client, and because we do agent-based backups as well. So in some ways we're sort of behind the curve. And we wanted to reuse our existing, as I said, startup shutdown scripts for things like Exchange or SharePoint or any other third-party products we have. So as we were discussing it, we sort of figured, we started trying to map out the dependencies of services and other services, but it got really hard really quickly, as you can imagine. If you've got 600 or 700 servers, and various things depend on each other. Like our business object server, if you reboot an AD controller, and it kind of sticks to one for some reason, and while that one's down, people can't necessarily log into the web interface. So there was just lots and lots of dependencies we couldn't map out. So we kind of took it a bit more abstract and came up with these basically windows. As I say, we've actually used some of the stuff in the grey area there during the day now for SSM itself and SCOM and that. So the orange ones, I think that's orange, unless I'm colourblind, is the dev and test servers. Generally, we have a dev and test domain, but we also have dev and test servers in our production domain. So it's all of those combined. And then the yellow ones is test and infrastructure services, like we have Bastion hosts for vendors to connect in. We want those Bastion hosts to be patched and available for them on the weekend if we have to call a vendor and ask them to come and fix their product on our server because we broke it with a .NET patch or whatever we did. So these are the sort of key components that we've utilised. We already had SCOM, so what we did was turn on, took a script off the internet which basically finds all the auto start services on your server and raised an alert if they're not running. It took a bit of fine tuning because there's a lot of services that auto start that don't need to be running all the time. But yeah, we quickly found those because every server would raise an alert just about them. So that way, if there's a third-party service like FileMaker Pro or whatever, it's not running, we'll know about it, even if we don't have a URL monitor or something else to monitor that. We went away for all those patching group, all those windows you saw before. We went away and created an AD group in each of our domains and an SCCM collection for that, based on those AD groups. So we have 2 primary domains, staff and student. So we made a script basically to create all those because there's so many groups, and then we also wanted to be able to add groups later. We didn't want to have to go, being engineers, we didn't want to have to go and click through the GUI for hours and hours and hours. So possibly we spend as much time as it would have taken to click through the screens writing a script. But more recently we have gone and created some more groups, so it's been quite helpful. So then there's a PowerShell script on all the servers, which basically what we'll use the task sequence for is call out to that PowerShell script, which will have a look for a couple of named task sequence, scheduled tasks, and call them at the start and end of patching to do whatever, link into whatever third-party stuff you want. And we wrote some PowerShell scripts for reporting. So we use the reporting services component, which I'll show you soon in the demo, hopefully, as the internet's still going, to sort of generate an XML file every 10 minutes, but for compliance and for a couple other things. So you can then just write your own custom, which we did, own sort of PowerShell, which sends an email to people so they don't have to open the SCOM console, which if you haven't got it open, it might take 10 minutes to open. Even on a solid state drive, it can be quite slow to open. So for engineers, being able to just check it on your phone or whatever when you're out and about in the weekend and then know that when I get home, I'll log in and fix that server was something that we really wanted. And it also gave us visibility to the managers too, for better or worse, about how the patching was going. This is just a sort of a flowchart on how the scheduled task gets called, or how the scheduled task gets called from the task sequence. So the task sequence is going along the top there. It starts out, we call it pre-patch custom actions. It'll call off this little wrapper script we've got on the server, and it will find a named scheduled task and call that if it exists. If it doesn't, it'll just carry on. And then also, one of the reasons for the wrapper script is to get the return code from that PowerShell script. So you can send a return code of 1 back to that, and it will stop the task sequence at that point. So if you say patch to SQL Server, and then it blue screened, hopefully the other server would then go, oh, that one blue screened, it's dead. I can't fail my databases to that one, so I'll stop the task sequence. That was the intention of that for our SharePoint environment. Just didn't work out quite as the way we expected. And that's just the code snippet. Don't have to understand it, but it's just calling out to the scheduled task and getting the result and writing it to a log. All right. How's the time? Oh, it's not too bad. I actually need to log into my machine, sorry. And I have a Mac, just to, so I feel part of the university. But I am, as I said, RDP back to my machine at work. Windows 10, I had a little side note here about Windows 10. I'm not sure if I should say it or not, but I will. It's a bit of a sidetrack. I'll just share a personal experience about using Windows 10. I've sort of came up with this morning, call it Windows 10, I've got a little acronym for it, NMT, which I'll explain in a second. At home we have a PC with a screen on the wall for we use to watch Netflix or whatever. My daughter knows how to use it. She's 4.5. You saw her in the picture before. She can turn it on and watch Netflix or open iTunes and listen to that because, again, we work at the university, so got to use some Apple products and some Microsoft products. I found her in tears one day because we'd asked her to stop watching Netflix, which she did, and that sometimes results in tears, but that wasn't the reason. Then she wanted to listen to music, which she said, oh yeah, fine, go and listen to your Wiggles or whatever, it's fine. However, she couldn't figure out how to get out of the full screen tile mode back to iTunes because I'd never shown her because I thought, I don't know, didn't really think about it. She just learned how to use the computer herself. So I knew exactly how she felt, I felt compassion immediately because so many times I've sat at work or whatever on an RDP session and opened the store or something and gone, oh, how do I get out of the store, And you're like rushing to fix a broken server or something, you've accidentally clicked store. So we upgraded to Windows 10 on that machine, and since then there hasn't been any tears, so I'm calling it NMT, no more tears. So yeah, it's my little plug for Windows 10. It said I've upgraded my machine at work and I haven't had any issues yet. So anyway, I'll carry on with the actual demo. If my notes come up. So SCOM monitoring, this thing that sort of we put in place. So that's a little script from the internet which will generate an alert like this. Opens. To say there's a service not running. If I can open it, there we go. So I actually stopped that service. As you can tell, we run EMC to back up our networker to back up our service. So that means if the service reboots while patching and that doesn't come up, we'll have an alert sitting there for us to check at some stage over the weekend and resolve. And that's, for those that know much about SCOM, we basically stole it from the internet. There's a little monitor that script someone wrote, which I'll find, from a long time ago, but still works in SCOM 2012-02, so we've still been using it. And script just runs through all the auto start services and finds any that are stopped, and as I said, generates an alert. And in the parameters here, we can put on all our exceptions. At some point, obviously, someone installed Google Chrome on a server. Don't know why. Not us, but yeah. As I say, we have a lot of vendors come in and do stuff, and sometimes they like to install browsers. And there's some services like these true Microsoft services that start and then don't need to be running all the time. And so we logged a call Microsoft and said, hey, you've got all these services that start and then they just stop again. Why are they auto start if they're stopped again? And they said, don't worry about them. So we just put them in there, so we don't worry about them. And the other thing we did with SCOM is create a little, so people didn't have to open the whole console every time, just a little dashboard. We also generate a daily email, and during the patching window we might generate that email a bit more frequently, so engineers have it in their inbox as well. Of course you can't get to SCOM from the internet. But then we also have this little web page and this little heat map, I suppose, since we're all into heat maps apparently. There's a lot of red there in tests because some stuff's broken. Some of it's intentionally broken, by the way. It's not, nothing to worry about. But the more red there is, obviously, the more broken stuff is. So we did that just as a quick look, also for managers to be able to see. So AD groups. So we have, as I said, heaps and heaps and heaps of AD groups, which can be a bit daunting at first. But basically we just put servers in them. And so in order to work out our dependencies, what we did was pick, pick all the 4 or 5 domain controllers we have and then go and put them into one, slot them into the 2-hour slots. So, and all the engineers sort of around the team did that, and all the engineers roughly understand their dependencies of their systems. So after the first couple of months, we might have broken a bit more than we intended, but it soon sort of worked itself out quite quickly. So what we did to create those groups and the collections themselves in SCCM was, as I said, write this little script. Might have taken a few days to write, but it's there now, and we can just call it if we've got some more groups we want to create. That'll go away and create the AD groups in the various domains and create our collections in here as well. So we've got a collection for each 2-hour window. So then we have a task sequence. I've put this one, I've just disabled a lot of the steps that we normally do because we don't actually want to sit there and wait for it to install Windows updates. It takes about 4 minutes to run anyway. But essentially it goes away, puts it into maintenance mode in SCOM. Again, we've got a little custom script which you can throw in some extra things to say, I also want to put that URL monitor into maintenance mode or whatever else in SCOM. Then it will call out to a little wrapper script which will call a scheduled task if it exists and run those actions before continuing on. And again, this one we've got don't continue on error, so it's not going to carry on if it breaks, and it's only going to run it if the file exists. So we push the file out with group policy, but as you know, group policy can be a bit unreliable at times, so the file didn't always exist. Then we install updates, and this is just a GUI to say we're installing updates. We also check for updates. Again, a lot of the stuff we might have Googled for it on the internet, maybe use Bing. And then we install updates. And then here's where we're sort of linking into our existing scripts for installing software. We connect to a file share using a service account, install our third-party software. Again, it's just a dialog box, but we've got this thing called NXLog we use to capture event logs and various other logs from our servers and put them centrally. So we'll keep that bit of software up to date. We'll keep the SCOM agent up to date with the same sort of build script, same install script we're using to build our servers with. Again, networker client. Hopefully one day we might transition to backing up VMs for VMDK, so we could actually have in there just to remove the networker client 1 month. VMware tools, again, we don't use Hyper-V, so patch our VMware tools. And then in the end, we just unmount that share if we can, and call that wrapper script again with a different parameter saying end, which will find the end task sequence. We'll show you in a minute. To sort of tidy up anything you want to get tidied up at the end of patching, or turn services back on. Some of our servers have manual start services historically. We don't necessarily build them like that anymore, but historically they had manual start services, so you want to stop those manual start services at the start of the patching and then turn them back on again at the end after the server's rebooted. Quickly show you what the reports look like. So we have this report which we run maybe on the Monday before Patch Wednesday. This just basically spits out what's in each group. So if someone calls up on the phone, or we have a scheduled meeting on a Wednesday morning with about 15, 20 of our clients. So if they raise an issue there, they say this particular system needs to be up at this particular time, someone can just sort of, Control F, find the particular server in this list, and then shuffle it to another group if need be. So there's a few things that sort of checking for as well, just to give us an alert. Like, if it's red, then it hasn't checked in, so does it exist still anymore? Someone might have not deleted the AD object after deleting the server. Those sorts of things, just also to chase our engineers up within the team on tidying up things. During the patching, we have this report come out a couple of times a day on Thursday, Friday, and then every couple of hours during the weekend it will come out so we can see the progress of it. So this is just showing us, if there's no servers in there, then yay, they're all patched. These ones have checked back in and said, no, I haven't actually. I've still got an update to install, but for whatever reason it's failed to install properly, or it hasn't installed. And there's a green line saying where we're up to. So you can kind of see where you're up to and what's still to come. And we still have around 35 to 50 manual patch servers. So we have a little group here which is showing the status of how far through we are patching those manual servers. So those reports, SSM. Like the patching status report, it's just grabbing, it's just a little PowerShell script basically is running over an XML file which got generated by reporting services, and it's just spitting out the contents of it really. So we just have a little reports description if it loads, which is going away and running that report on SQL Server every 10 minutes. So we have the latest up-to-date data. So if that ever loads, it doesn't load, no, here we go. So yeah, we're just finding all the machines which are not compliant with the particular upgrade group that we've deployed, and just throwing them into an XML file on the server so we can query it and send a nice little email out. So I will jump over now and show you. We're actually going to. I'll run these task sequences on these SQL servers. These are our two SharePoint SQL servers in a 2012 always-on configuration. When we built them, I wrote a little script which you could call to fail the what we call DAGs, if you know about SQL always-on DAGs between the servers. And generally we run them active-active, so we have half the DAGs on one server and half the DAGs on the other to try and maximise performance. So at the moment it's sitting in its sort of preferred configuration with odds on one server and evens on the other server. So I'll run this. Normally, as I said, schedule task, we set it to run at that particular, 1 minute past the window or on the window, and it will run immediately then. I'm just running it manually so I didn't want to commit to running it at exactly 9:30 or something this morning. Hopefully it'll pop up. Yep. So it ran the Scott maintenance mode, and now it's running what we call pre-patch custom actions, which you should find is running this little script here. Yep. Which itself is calling out to this other script which we've written. One of the reasons we did the scheduled task, I'm not that much of a coder. I've done a computer science degree, but I don't like spending all my day coding. One of the tricky parts was a lot of our scripts already use existing service accounts, so we didn't want to have to update all the permissions and figure out what we needed to do to make them run as a system account. So SSM by default runs as a system account on the machine, which often has enough privilege to do what you need it to do, but sometimes, like with Exchange or SQL, you don't necessarily want to grant the system account full rights into that system. So this is just I guess the reason we use the task. Schedule task is a nice sort of elegant way, I guess, of way of just jumping over to this other user account without having to write some complicated code which I thought was complicated anyway, to switch users or save the password on the server somewhere and that sort of thing. And all our engineers know how to create a scheduled task, so they didn't have to run a special PowerShell script or whatever to encrypt the password or anything like that. Anyway, we'll jump back here. This is actually, I talked too long. It's actually already failed itself over to the other server, so they are all secondary now. Jump over to the other server. Little error just while it's still resyncing. That script itself actually writes out a file here, so it goes away and does some cluster checks and stuff as well. So it's actually saying, is my other server up at all? In which case it would have returned an error and it would have stopped the task sequence immediately. And this is just saying it's failing them over, and it's failed that one over, and it's just waiting for the secondary copy to be back in sync again, which it will be very shortly, I suspect. Yep, so that's back in sync. If we hop back to that server quickly. any second now. There we go. So now it's just going to go install updates. So yeah, there should be no clients connected to that anymore. If we hop back to this is the site that it's serving. If we hop back here, hopefully it'll load. Yep, still loading, still works. So there might have been, if someone hit the page at the exact second one of the DAGs was failing over, they might have got an error. But most users will generally just refresh their browser and carry on. But again, this is happening at 2 a.m. or 4 a.m. So users shouldn't really, well, at least they can't call us at 2 a.m. because we won't answer our phone. So if nothing else, we avoid that conversation. So that task sequence is finished now. Just done what it do. Imagine it, installing updates, rebooting, that sort of thing. So then we hop back to the other one. It's all active on there. We'll run the update here as well. And it'll chug away and do its thing. Is there any questions at all at this stage? No? No sidetracks people want to take me on? So the question was, are we using the same site to manage desktops? We are. We provide it as a service to our departments. There's only sort of been a limited uptake at this stage because some of our departments already use like WDS and stuff, so they've already, and they're very busy, so they don't necessarily have the time to jump into CCM, but some are, yep. So we're using a single site for around 600 Windows servers and probably only got about 400 or 500 desktops on there at the moment, but the intention is to create more servers if we need to. And as I say, this is servicing another domain as well in a different forest, well, 2 other domains in 2 different forests. So. Yep, so within, it's chugging away, we'll see that. I'll show you that in a second. So this is just slowly failing its services back to the other server. But I'll quickly jump to the SSM console. What we've been doing is we create what we call privileged accounts for our departments to use if they want to use AD. So we use their privileged account group and their organisational units that we create for them. So, oops, I can open that up. So we create an OU under here for, this is just test AD. In production there's probably about 30 there now. And they can join their computers into those particular OUs. We don't do any, at the default domain policy level, we don't do anything. So they can join the machine to the main and be an admin, and that's cool. We just want them to join it to the domain, because then when they leave, we can disable their AD account and they can't log in. But then we'll create a collection based on, say, academic services, and we'll limit their access in SSM to that collection. So they have to have their machines in there for it to work, if that makes sense. So that's how we're protecting it. Relying on the inbuilt security in SSM, which Microsoft has said works fine. So, and we haven't seen anything to counteract that yet. Or haven't seen anyone hack their way around. So, not that anyone's tried probably, but you never know. Sorry, let's jump back to the demo. It's still. Sorry? A couple of weeks, I suppose. Yeah, we initially started deploying, doing it with a software update group. So we had a software update group, and we'll deploy that. And as you know, you can set a deadline for it, but you can't say when it will install. It'll install based on maintenance windows and an evaluation schedule. So we did that the first couple of months, but we found that we had these 2 windows, and depending on our evaluation schedule, the updates would install at the end of the window. And because we hadn't necessarily patched these guys for like 3 years, 5 years, whatever, Windows 2003 servers that were upgraded from Windows 2000, which was upgraded from NT4. They had a lot of updates installed. They'd patch what they knew about, they'd reboot, and then they'd go, oh, I don't have any more updates, or whatever. Well, they wouldn't then detect, and then they'd end up with still updates to install. And it wasn't really ideal for us, really. We wanted to know when it was going to happen. So then they might detect updates. They'd do that on Friday night, but then they wouldn't detect updates again till Saturday sometime or whatever, if they're a slow server, or Sunday, and then they'd find them and go, oh, my deadline's back then, I'll just reboot it again, or a Monday morning. And so that wasn't really cool for us. Even though you had a maintenance window, admittedly we'd set, install them outside the maintenance window if you had to. We probably shouldn't have done that, but at the same time, they still would have been left there unpatched. Whereas with the task sequence, we actually say install updates about 5 times. So they reboot and we'll check for updates, install updates, check for updates, install updates. It might drive you a bit batty if you're manually installing them and watching it, which it does for some of the stuff, but it's just an incentive to do it automatically, really. Sorry? Not a lot. Our engineers do it when they build a machine. It's part of the build process now. You put it in a group. If you don't, it will turn up in that report, that email at the bottom, and we'll tell a manager, and he'll go and growl at them. And so that's now doing the post-patch custom actions. So it's install its updates. Hopefully what it's going to do is redistribute them. So the evens will be active on the even server, and the odds will be active on the odds server. You could do. Yeah, you could do. We don't at the moment, but yeah. Yeah. Yeah, so if you've got a script that can say yes or no, do I want to continue, and all the logic you want to make up that yes or no, that's the intention. So some people already have those scripts, and so you can just, as I said, create that task sequence with the schedule task. I keep using the two terms interchangeably, which is a bad thing. So there's one called begin, which runs at the beginning, and there's one called end, which runs at the end. So instructions for engineers are create that schedule task, put the credentials in for the user you want it to run as, and that's basically it. But so we still leave it up to the engineers or the vendor to give us the script, or write the script to do that. But as I say, we do have a number of things which a standard server will have a weekly full and a nightly incremental. So this will cause, some of these will cause the nightly incrementals to fail. Things like Exchange, the nightly incremental will fail, but sometimes they're running for 20 hours anyway, so we haven't tried to necessarily work around a backup schedule for them, but we could. We have scripts which can query we have a compliance scripts which can query the time of the backup from the backup server, and you could work that into it if you wanted to. You could also, what we're intending to do is write a script which will call out to, we use NetScalers now in a new network, so call out to a NetScaler to put it into, take it out of the VIP if you want it to at the start, and then put it back in the VIP at the end. Maybe query the VIP and say, are there enough healthy members in this VIP? If there aren't, then I won't patch my server. Those sorts of things. Not very often. Most common thing is a .NET update will break some third-party software. That's what I've seen. Things like FileMaker Pro generally run Java and other things, so Windows updates don't tend to affect them too bad. SCOM. So as I say, with the pre-check, you could check to say, is my partner, is my peer up or down? And we should do more of that. We haven't necessarily had the time to do it on all our servers and services. We've done it for things like the core things, Exchange and SQL Server. But as time allows, we're slowly adding to that, but without having to change anything in SSM. So I guess that's the nice thing about it. So that guy's finished, and he's back to normal again. And I probably should have been reloading this page during that time to show that it was still working, but it is. So, anything else I want to show? The other thing on the reporting is we again have a little PowerShell which will go away. We do change control. We didn't necessarily do it consistently, but so what we did was just write a script to do it for us, because we're not necessarily going to remember to do change control all the time. Some may say never, but we do it. But the script does it for us for our servers that are patched. So when it sees it's patched, it runs once a day. It'll send an email to our change control system. We use a thing called Jira, if you know about it, Confluence. Send a little thing there, and so we have a record of it there as well. So I'll carry on with some more questions. So I need to switch back to here. Sorry. So as you saw, we're down to around 35 manual patch servers in production now. So from 400, we were patching 100 to 150 per engineer for a while there on a weekend, which was pretty tiresome. Error rate, as you saw, there's some errors for various reasons. SSM client doesn't work properly, or something goes wrong. It's around 10 to 20 servers, or maybe 5% on a good month, or less on a good month. Managers can see how it's progressing, so they can call up the manager knows who looks after that server, so he can call them up directly rather than calling whoever's in charge of patching for that week. You don't have to do that, and if managers can see that it's finished, then they don't have to bug us either. So to sort of come back to the idea of it, of the notion of diversity demands creativity. At the university we have a lot of problems and requirements which aren't perhaps as prevalent in the corporate space. I think, I've been out of the corporate space for a while, but I still think of it as, you've got 100, 300 employees and they all run Windows and they've all got a Windows phone, and you use an MDM and you control it. We're not like that at all. So within our team at Otago, it's not, no is really a response we're allowed to give or able to give to a varying request from a client. If we say no, that they're more than likely just going to go away and do it themselves in Azure or wherever else, which could be fine for their requirements, but it could be something which you don't want, like there's a patent pending on it or something, and you don't necessarily want it there for legality reasons or whatever, which I know the government said it's legal to put your stuff in Azure, but I don't know, the university itself hasn't yet figured that out for itself, because we're a government-funded entity, but we're not, we are a private one as well. And we're at enterprise scale, so we need to find, we still need to be able to do stuff without burdening ourselves. So we need to find these sort of creative solutions to not burden ourselves, so we can have a life on the weekends. I'd like to encourage you to think of your own problem areas of your environment, and where it makes sense to develop your own solutions to these problems, not necessarily just copy mine. In fact, it's probably a bad thing if I just gave you mine. It's not going to help you. You're better to work, build up your scripts and things that glue your environment together yourself, because you understand how it works and it's going to be unique to your environment. So, any further questions? So for some things we've got SCOM URL monitors. We also use a thing called SolarWinds, which will do sort of log into a web page and check it. And SCOM, we've got that going as well, so it will log into our corporate apps or whatever, and go, you can still log in. So we're relying on SCOM for that, and where we find things, where we miss things, we add them to SCOM at the moment. So further questions? Thanks for coming. I'm only just going through my required slides now, so feel free to leave. Yeah.